All right, so this is the assignment from yesterday. So we talked a little bit about how if your delta column is constant, then it's a linear function. And remember, this 3 right here is your delta, which is the same thing as your slope or your rate of change. In this one, your delta column is not constant, so you need to go out to delta 2, and because your delta 2 column is constant, you get this quadratic function. And then if you look at 3, 4, and 5, all 3 of them, what they have in common is they have this little x for the exponent up here. And if you look at each one of your ratio columns, so your divide column, this number here matches that base. This number here matches this base. This number here matches this base. So really, we could kind of label this as our B column for base, right? So any exponential function is going to have a variable for its exponent, and then the base is what you multiply by. It's what your rate of change is for that, or your ratio, sorry. Okay, so just a quick recap over your basic rules for exponents. First one that we talked about was when you multiply bases, you add your exponents together, and your bases have to be the same in order to multiply your exponents, or in order to add your exponents. The second one that we talked about was when you are dividing the same base, then you subtract the exponents. If you have a power to a power, then you multiply the exponents. And then probably the one that everybody forgets but is tricky easy is anything to the 0 power is always 1. And somebody else brought up one today that I think we can probably add to this one. Anything to the first power is always itself. So anything to the first power, a to the first power is a, 10 to the first power is a, or is 10. Negative 72.3 to the first power is still negative 72.3. So what we're going to be looking at today is, we already talked about linear functions, that's a straight line. We've talked about quadratic functions. That's a parabola, anything to the x squared. So this would be like mx plus b. This would be something with an x squared in it. And so the one that we're going to talk about today is exponential functions. And exponential functions, we're going to talk about that one here in just a second. So we want to be able to graph exponential functions. And then this one is not so much an important one right here. Our big objective today is that we just want to be able to graph those exponential functions, and we'll get to that one probably tomorrow. So this is what an exponential function is. So it's always got this form, a times b to the power of x. And there's a couple of really important things that you have to know. A cannot be 0, b has to be bigger than 0, and b cannot be equal to 1. So if you look back, when we were talking about in the assignment from yesterday, each one of these represents your b. So this would be, your a here would be 1 times the base to the exponent of x. This right here, this 3, comes from this right here. So 3 times 5 to the x. This would be 1 times 1/2 to the x. So they all have a times b to the x power. So if you think about the 2 rules that we talked about, a can't be 0 and a can't be 0, b can't be equal to 1. Well, if a is equal to 0, 0 times anything is still just 0. So it doesn't matter what your exponent is, it doesn't matter what you choose for x, your answer is always going to be 0. And if b is equal to 1, 1 to the anything power is always 1. So your a is going to be a fixed number. So every time that you multiply, it doesn't matter what your exponent is here, you're always going to be taking 1 times a to get a. All right, so there's this really fun vocab word that we have. It's pronounced asymptote. And the asymptote is just a line that the graph approaches, but it will never touch and it will never cross that asymptote. Okay, so in exponential functions, we always have asymptotes. So, how can we graph y equals 2 to the x power? So if you think back to when you first started learning how to graph equations, we didn't really know anything about y equals mx plus b, so we had to use these xy tables. And again, we don't really know how to graph exponential functions, so what we're going to do is we're going to use an xy table. And I'm just going to cut to the chase on this one. We talked a little bit more about it today, but what you want to do is you always want to look at your exponent first, and you want to determine what your balance point is. And the balance point is just the number that makes your exponent 0. So if your exponent is just x, then your balance point is just going to be 0. Okay? So that's going to be the middle number of your graph. And we really only need one number before that balance point and one number after that balance point. So we would use -1 and +1. So 0 is not always going to be the number that you use, and we'll look at some of those examples here in just a second. But basically what you're doing is you're taking these numbers here and you're putting them in for x here. So you would have 2 to the -1. Well, we don't like negative exponents, so in order to get rid of them, we have to do the reciprocal of this number right here. And so the reciprocal would be 1 over 2 to the first power, and 2 to the first power, anything to the first power is always just itself. So remember, this is your x coordinate and this is your y coordinate, so that gives you your ordered pair. So the first ordered pair that we're going to graph is -1, 1/2. -1, 1/2. Second time around, we're going to use 0 as our input. And this one, anything to the 0 power is always 1. So the ordered pair that we're going to work with is 0, 1. So 0, 1. And then the last one that we're going to use is 2 to the first power. Anything to the first power is always itself. So the ordered pair we're going to work with is 1, 2. So 1, 2. Okay, now, we have an asymptote on this graph, and if there's nothing added after our exponent, then our asymptote is going to be on the x-axis, okay? So then our graph is going to look like this. On this direction, it's going to just keep getting closer and closer to this asymptote. It will never touch it, it will never cross it. It just keeps approaching it, getting closer and closer and closer and closer. All right, so example number 2. So our balance point, the first thing we want to look at is what is going to make that exponent 0. So what can we put into x that when we subtract 1 we get 0? So our answer would be 1. So then we want to take one number before our balance point and one number after our balance point. So again, if we put 0 in, you would get 2 to the 0 minus 1 power, which is 2 to the -1. 0 minus 1 is -1. And we don't like negative exponents, so we have to do the reciprocal, which is the same thing as 1/2. So you would have 0 and 1/2 would be your first point. And again, there's nothing being added on back here, and so we know that our asymptote is going to be on the x-axis. Okay, again, if we plug 1 in here, 2 to the 1 minus 1 power is the same thing as 2 to the 0 power, and anything to the power of 0 is always 1, so the ordered pair that we're going to graph is 1, 1. And the last one, again, we're just going to plug 2 in for x. 2 minus 1 is 1. Anything to the first power is always itself. So we're going to graph 2, 2. Okay, again, your graph is going to approach this asymptote, but it's never going to touch it and it's never going to cross it. We're going to skip this one for now. We're going to look at this one next. So if we look at this one, the first thing we want to do is look at our exponent, and we want to find the balance point. So what number can we put in for x to make our exponent 0? That's a 0. So we want to use one number before the balance point and one number after the balance point. So if we put -1 in for x, we have 2 to the -1. But now we have this -1 afterwards. So this is telling us where our asymptote is going to be. So instead of being horizontal on the x-axis, it's going to drop down 1. So now our asymptote is going to be at -1. And then we have to remember that we need to take this whole thing and do the computation with everything. So 2 to the -1 power is the same thing as 1/2. And we still have that -1 there. So if we take 1/2 minus 1, we get -1/2. So we have -1, -1/2. So -1, -1/2. If we plug 0 in, we have 2 to the 0 power minus 1. Anything to the power of 0 is 1, so 1 minus 1, which is equal to 0. So the next point we're going to plot is 0, 0. And then the last one that we're going to do is 2 to the first power minus 1. So anything to the power of 1 is just itself. So 2 minus 1 is 1. So now we're going to plot 1, 1. So 1, 1. So our asymptote is at -1. It means that our line is going to approach that. It's going to get super, super close, but it's never going to touch it. It's never going to cross it. Okay, so I want to back up here and I want to look at number 3. So if we look at the exponent, we want to figure out our balance point first. So what number can we put in here to get our balance point? Equal to 0. That's a 0. Use one number before, use one number after. And then there's nothing being added back here, so we know that our asymptote is going to be on the x-axis again. So if we put -2 to the -1 power, we don't like negative exponents, so we're going to do a reciprocal, and that's the same thing as -1/2. So -1, -1/2. Okay? Again, we're going to put -2 to the 0 power equals, anything to the 0 power is 1. Here's the catch with this one. If we say that -2 to the 0 power is equal to 1, and we plot the point 0, 1, we've crossed over that asymptote. And we know that that asymptote there, that line can't be crossed by our graph. So here's the trick to this one. Because there are no parentheses in this, what it's really saying is that you're taking the number to the exponent and then you're taking the opposite of it. So really the first thing you're doing is taking 2 to the 0 power, which is -1, or the opposite of 1, which gives you -1. So you're going to plot the point 0, -1. And then the last one, again, you have -2 to the first power. Anything to the first power is always itself, so you just get -2. So the next point we're going to plot is 1, -2. So 1, -2. Now, if you notice, this graph is a little bit different from the graphs that we've been doing. And the reason for that, this one is below our asymptote instead of above our asymptote like the other ones. And the reason for that is because of this negative sign here. So that negative just reflects it across that asymptote. Okay, and then we have this one here. So if we have 1/2 to the x power, the first thing we want to do is we want to look at our exponent and we want to figure out what is going to make our exponent 0. In this case, it's just 0. Pick one number before and one number after. So if we do 1/2 to the -1 power, we just do the reciprocal, which is 2 over 1, or 2. So the first plot we're going to point is -1, 2. And again, there's nothing being added after here, so we know that our asymptote is going to be on the x-axis. We do 1/2 to the 0 power, we get 1, so we're going to plot 0, 1. And if we plot 1/2 to the first power, that's the same thing as 1/2, so we're going to plot 1/1/2. And this one is also a little bit different. So if you notice before, most of our graphs started low over here and ended up high on this side. Instead, this time it's starting up high on the left and ending low down on the right. And the reason for that is because the base here is between 0 and 1. So anytime that your base is between 0 and 1, you get what's called exponential decay. And when your base is greater than 1, you get what's called exponential growth. So you start low and you get high. We're going to do this one here. I'm going to add this on for us though. Okay, so first thing we want to look at is we want to look at the exponent. So what number can we put in for x that is going to make our exponent 0? So that's 1. We want to take one number before and one number after. So this number right here is going to tell us where our asymptote is at. So it's at +2, so we just start, our asymptote would normally be on the x-axis. This one's just bumping it up 2. So our asymptote now is going to be at that horizontal line. And your asymptote for exponential in this case is always going to be horizontal. You'll never have anything that's slanted, you won't have anything that's vertical, it's just always going to be horizontal. So it'll be somewhere crossing the somewhere crossing the y-axis. So again, if we put 1 in here, if we put 0 in, we get 1/2 to the 0 minus 1 plus 2. 0 minus 1 is -1, so we have 1/2 to the -1 plus 2. This means that we just take the reciprocal, so we have 1/2 plus 2, which is 2.5 or 5 halves or 2.5. So we go 0, 2.5 is the point we're going to plot. So 0, 1, 2.5. If we plug 1 in, we get 1/2 to the 1 minus 1 plus 2. Anything to the 0 power. 1/2 to the 0 power plus 2. So anything to the 0 power is always 1. So 1 plus 2 is 3. So the next point we're going to plot is 1, 3. 1, 1, 2, 3. And if we plug 1/2 to the second power plus 2, that's 1/4 plus 2. Oh, sorry, 2 minus 1. Ooh. 2 minus 1, which is 1/2 to the first power plus 2. Oh, good grief, I did this one wrong. I forgot to take the reciprocal of this one, I'm sorry. So this would be 2 plus 2, which is 4. There we go. This one is going to be 2.5. So our point would be 2 and 2.5. So 1, 2, 1, 2.5. So again, approaches the asymptote, doesn't ever touch it, doesn't ever cross it. And I think we're done. So the assignment that goes with this is the little quarter sheet that had 10 of them to graph, I think. If you have any questions, feel free to email me, talk to me in class. That's it.